Morning. College algebra is mostly great at graphing. So I want to talk about some basic graphing techniques today and just some basic characteristics. So let's see if we can pull up a whiteboard here. When we do graphing in college algebra, we're generally starting with, this is just a regular number line. Got 0, 1, 2, 3. So the positive numbers are going to the right, and the negative numbers go to the left. Well, back during the Renaissance, a philosopher and mathematician named René Descartes came up with the idea, or at least he gets credit, of taking a second number line and putting them so that they crossed at their zeros. The second number line goes up and down, and he thought that up would be a good way for the positive numbers to go, and down would be a good way for the negatives to run. And you'll have to excuse the wiggliness of my lines here, because that's about the best we can do on this. So positive horizontally is to the right, horizontally negative would be to the left. On the vertical, we call these axes. Axes with an E is plural. Axis, A-X-I-S, is singular. And I know a lot of this is really, really basic, but when you're going to start, that's a good place to start. So we usually call the horizontal axis the x-axis and the vertical axis the y-axis. Nothing magical about those letters. I think perhaps they just, X doesn't get used that much in English class, so they thought they'd use it in math, and then Y just comes naturally after the X. So this is called the Cartesian coordinate plane. It's a plane because it's flat, but it's two-dimensional, up and down. You might call that length and width. The coordinates refer to the numbers that are used to identify any particular point in this space. And Cartesian actually is named after René. These two lines break this space up into what you can see is 4 different spots, 4 different areas. They typically, these are called quadrants. Quad is 4. And they number them with Roman numerals traditionally, with the first one in the upper right, where everything is positive, is 1, and then they go counterclockwise. So this is quadrant 2, quadrant 3, and quadrant 4. Now, any individual point in any of this can be identified by using 2 numbers. The first number tells you how far it is horizontally to the left or the right of the origin. This point right here where the 2 zeros are is the point 0, 0, and it's called the origin because it's where we always start. So the first number we usually represent it with an X, and then the second one is Y. The first number is always how far you go in a horizontal direction, and the second number is always how far you go in a vertical direction. And if you ever forget, just alphabetize them. H comes before V, X comes before Y. So to get to this point right here, we would have to go 2 units to the right and then 1 unit up. So we call this point 2, 1. Now, this is an ordered pair because it's a pair, obviously, and order matters. The point 1, 2 would be where you started at the origin and you went 1 to the right and then 2 up. So this would be the point 1, 2. Every single point in the first quadrant has a positive horizontal number and a positive vertical number. To end up in the second quadrant, you have to go to the left and then up, and you can't switch those. The left, right is always the first number. So everything over here has a negative X value and then a positive Y value. Every point down here, you go left and down, so it has a negative X and a negative Y. And every point in the fourth quadrant has a positive X and a negative Y. Let's get another screen and have a clean slate. An equation in 2 variables is what we use to define a graph, or you could say that the graph defines the equation. An equation in 2 variables is always going to have infinite solutions. Even if we just wrote for example, X equals 3. In 2-dimensional space, this is a line containing every point whose X is equal to 3. For instance, while the point 3, 0 definitely has 3 as the X value, so does the point 3, 1, and the point 3, 2, and 3, 20, and 3, negative 7/5. Every point whose X value is 3 in 2-dimensional space is a solution to this. And when you look at the points, you've got over 3 up 0, over 3 up 1, over 3 up 2. You can see that anytime you go over 3, regardless how far up you or down you go, you're going to end up on this vertical line. So the graph of X equals 3 is a vertical line going through the 3 on the x-axis. Likewise, a line like this, a horizontal line, if this is the graph of every point whose X value is 3, this is the graph of every point whose Y value is 2. Notice that they cross at the point 3, 2. Any point in the form something x plus something y equals some number, where a, b, and c are real numbers, is going to be a line. Notice there's no exponents. And no variables in denominators. Or in radicals. You could have the square root of 2x, but not the square root of 2x. Anything that can be written in this form is called a linear equation or a linear function in 2 variables. We usually know we're working in 2-dimensional space, so we don't constantly say that it's in 2 variables. It's called that because the graph is a straight line. We're going to do a lot more about lines later on.